Hey guys, welcome back. So today we're working on this 1200 watt Kawasaki generator. This one was dropped off by a local subscriber, Chris, who I believe said he found it in a friend's shed. That said, I didn't get the backstory on it. I don't know the history of this machine. For all I know, there is nothing wrong with it and it's just gonna run. But I kind of doubt it's gonna be that easy. Judging by what I saw in the tank, I'd say it's actually been a while since this machine has run. There is a fair amount of corrosion and rust, so that is something that does need to be dealt with. But I don't want to start there. I want to make sure everything else is good, and if it checks out, then we'll clean that tank up. So, I have pulled the engine over. We have good compression, so it should run as long as we have spark and fuel. So let me set up a little bit better. And I want to check the basics. And if everything looks good, we'll add some fuel, pull it over, and see if we get any signs of life. It took me a second to find the oil fill. It's actually hiding behind this panel. That just flips open, and we got the oil fill right here. So we'll take that out. Just a tiny bit on that dipstick. And if we test it the proper way, it's right at the bottom. So yeah, we need some oil before doing anything else. Yeah, it's hard to see because the oil is so clean, but we are full now, right to the top. So we know we have compression, we now have oil. Do we have spark? And that's a bit of an unknown because the ignition switch is kind of broken. So I'm not sure if it's on the on or the off position. So I say the easiest thing would be just to pull this cover. We'll gain access to the spark plug wire. We'll throw our spark tester on there and find out. All right, so we'll just get the spark plug wire off the plug, and we'll put this inline spark tester like so. And we'll just pull the engine over a few times. Keep an eye on that light. Hopefully we see it blinking. Beautiful. We have spark. So I'm going to skip ahead here and just pull the plug. We'll add a little bit of fuel directly in the cylinder, pull it over with a light plugged in, and hopefully the engine starts and we see that light turn on. I'm going to put a little bit of two-stroke fuel in there. Not sure how long it's been since this engine has run. So adding that two-stroke fuel with a little bit of oil, it's going to do nothing but help this engine out in the first start, and I would say quite a few years. All right, let's give this a try. I've got a light plugged in and turned on. Now, it's not going to run for long. There's only a little bit of fuel in there, but hopefully it runs long enough and gets up to speed so that we see that light turn on. No light, but the engine sounded really good. I'm not sure how well that came across, but this engine is very quiet. So I'm going to pull the plug again. We'll give it a little more fuel. This time I'm going to open the choke up, see if it can get up to speed. right, let's try this again. Nice. Very nice. We've got power, and that light came on nice and bright. The engine sounds really good, so I think we pretty much have everything we need, except maybe fuel. So I say we pull the line going into the carburetor from the tank. We'll just feed the carb directly with some fuel, see if we can get it to run a little bit longer on its own. Actually, before I pull that fuel line off, I'm going to pull the airbox cover off. I should have done that before starting the engine for the first time. Usually these have foam filters which tend to biodegrade and turn into dust. And in this case, we have no filter, just a bunch of spider webs. So we will need to make a new filter. But for now, let's just get the fuel line off and feed it some fuel. Oh no. The brass insert for the carb came out. Yeah, that is not a good thing because this carb, it is discontinued and not available. So that we're going to have to deal with. So let me work on this a bit. I don't want to actually damage it. Right now it looks like it's intact. But yeah, that is not a good thing. And I'm actually trying to avoid cutting this line, but I might have to. My concern is this line, although it's old, it's in very good condition, and any fuel line I put on there now, it's not going to last as long. It's not a formed fuel line either. So I don't want to make things worse than they already are. I don't see any signs of adhesive or solder, so I'm thinking this is just a press fit. So I don't actually have a press, but I think if I just tap that back in carefully with a brass drift, maybe we'll get lucky. Otherwise, we can pull that back out and try something else. It's in there pretty tight, so yeah, I guess we'll add some fuel, see if it leaks. So I'm looking for two things here. I guess first off, are the needle and seat working? And then are we going to leak on that brass tube that just fell out? It's taking quite a bit of fuel, so I'm thinking the needle and seat are likely not working. So I'm going to stop adding fuel and give it a second. Yeah, so far so good. Throat of the carb is dry and nothing's leaking on the ground. So I'm going to keep going until either that flow slows down and hopefully stops, or we flood over. Looks like we're good. The fuel stopped advancing right there. It's holding steady, and I don't see any leaks. So let's try to start it. Regardless of whether the carb can run the machine or not, I'm going to pull it off and clean it. You know, this machine, I haven't quite placed its age, but my best guess would be late 1980s or early 1990s, and I'm sure the carb has not been cleaned in that time. Anyway, if it does start, you know, I may not be able to shut it down, so I'm either going to have to let it run out of fuel, or if something goes wrong, pull the wire off the spark plug. So right now the choke is on. Let's give it a few pulls and see what we get. And that was kind of abrupt shutting off. So I wasn't looking at the low oil light, so I'm not sure if it ran out of fuel or if we have some other issue. So I just turned the choke back on. Let's try to restart it. Low oil light. Interesting. That was impressive. It started first pull. I was able to turn the choke off right away, and the engine ran fine. However, that was short-lived. About 5 seconds later, the engine shut down abruptly like it lost spark. And after restarting it, I paid closer attention to that light, and I could see that the oil system was kicking in and shutting things down. So yeah, likely we have a fault in that system. You know, we were low on oil to start with, but we topped that off. So I will double check that, but I'd say likely we need to open up this control panel, trace the wires for the low oil system, and see if we can't repair it. You know, as far as the carb goes, I'm going to clean it anyway, despite how well it runs. And we do have a bigger issue. This tube, although it seemed to go in well initially, you can see the carb is all wet with fuel. So that has to be solved. Anyway, let's check out the oil system first and see if we can't get that working correctly. Yeah, we are definitely not low on oil. So, yeah, we have issues with the oil system as far as detecting the level goes. So there's usually two components. One is inside the engine. It's a float that grounds out when we're low on oil. So if that is bad, likely, you know, it's not worth fixing. But there's a second component outside the engine. That is the low oil module. So it's not actually the switch that grounds out the coil. It's the module. And the module only grounds it out when it receives a signal from that switch inside the engine. It has to receive a signal for about 5 seconds, and then it starts the shutdown, and it holds the shutdown or latches it in place. So even if the float all of a sudden is satisfied that there's not low oil because the engine's slowing down, the module continues the shutdown to fully get the machine to stop. So yeah, let's get these two screws out up here on the control panel. We'll pull this forward, see if we can find that module. Likely it's behind here, but it could be elsewhere. So we won't know until we take a look. No, that one's not coming out. It looks like there's just 2 wire harnesses coming out of this control panel. So the one here I'm unplugging now, I think that's the one that ultimately is shutting the engine down. It goes over here to this module. And then we have these wires coming out of the stator, which I'm sure is the main output. Yeah, things look pretty straightforward in here. I don't see any issues as far as the wiring goes. This is the low oil light right here and the ignition switch. So there's actually nothing in here that should be shutting the engine down except this switch. When you push the switch in, it connects this green wire, which is ground, to this white wire with the red stripe. And that feeds a ground signal into this connector, the bottom pin, which connects over to that module. So let's take a closer look at that low oil module. To test this out, you are going to need a multimeter that can measure resistance. So I've got this one set to measure in the ohms scale, and I'm going to start with this 3-wire connector. I'm expecting to see a few things here. We need a source of ground, which is being picked up by this brown wire. So that goes up to the ignition switch. When you turn the switch off to shut the engine down, we should get a signal back, a ground signal, into this module. And then lastly, the low oil light needs power, and it gets that from the ignition coil. So the 3rd wire, I'm thinking, is going to connect over to the primary on the ignition coil. So I'm going to put one of these leads on a source of ground and just probe these wires. Starting on the right, which is the white wire. And we get a very low connection, 2.5 ohms. So that is the source of ground for shutting the engine down. Let's check the yellow wire with the red stripe. We get nothing. So likely that is the ground that comes back when you hit the ignition switch to off. That leaves the last wire, which theoretically goes to the primary on the ignition coil. And I would say likely that is the case because we're a lot higher at 2.18 thousand ohms. So let's check these wires. We know the brown is ground. The black should go to the ignition coil. So if we unplug it here, I'm expecting to see about the same reading we just got of 2.18 thousand ohms. Of course, it could be a little different because that was going through this mystery black box. There we go. That is a really low connection. So 1 ohm might be okay. I'm actually not sure. Let's just check it to the module. And we get a pretty high connection there. So that's kind of interesting. I wouldn't expect the module to have any connection to ground at this point. Anyway, let's unplug the low oil switch. Make sure that doesn't have a connection to ground. Let's just check the switch to ground. We should have no connection unless it thinks we're low on oil. And at least with the engine off, there is no connection. So I don't think we have a fault with at least the insulation on the wiring. And the switch might actually be good. I'm getting a little more suspicious of what's going on here. The primary and the ignition coil seems kind of low. That might be okay, though. I don't have the specs on this engine. And this wire here, I would not expect to have any resistance unless the ignition switch is turned off or we're getting a signal to shut the engine down from the switch inside the engine. And both those switches are disconnected. So, yeah, that is suspicious. Of course, there are electronics in here. So what it does when it's off, who knows? That might actually be normal. So what I'm going to do here is just reconnect this wire, which runs to the ignition coil to shut the engine down. I'm going to leave this disconnected. We'll start it, see if it runs for more than 5 seconds. And if it does, then we know that's the problem. If it shuts down again, then we have an issue in here. So I'm going to restart it just like this. And the only way the engine can shut down is if I pull the wire off the plug, or this module shuts it down, because the ignition switch fully disconnected and the low oil switch as well. So this is the only thing in circuit, this wire going to the coil and the brown wire connected right there. So let's start it and see what happens. I'd say that was pretty conclusive. The engine kept running just fine. I actually had to ground out the coil manually to shut things down. That said, I do want to do one more test. I'm going to set up the multimeter. We'll measure resistance. I'll put one lead on that yellow wire coming out of the engine, which is the low oil switch. And the other lead I'll put on a source of ground. We'll start the engine, keep an eye on the meter, and see if we see that switch grounding out. Now I'm not sure what to think. Either we have an intermittent problem with the switch inside the engine, or that's not the issue. So if that's not the issue, it only leaves something wrong over here with the control panel. So let's take a closer look at this. So I've set the multimeter to test in continuity mode, which just means if you have a really good connection, it'll beep. And the wires I'm interested in are right here. This is the ignition switch and the low oil light. So we'll start with the switch. We determined earlier that the black wire and the white with the red stripe are for the light. That does not work, but let's just verify that. So white with a red stripe should go to positive, and it does. And the black wire should go to negative, and it does. So those are definitely the power for the light bulb. We also have a green wire that should be ground, and it is. And then we have this other wire here. It's white with a black stripe, and that should take the ground from the green up to this connector when you turn the switch off. So if I probe on the white wire with the black stripe on both ends, we get a beep. So that switch seems to be good. And just to make sure, if I check from this wire, the white wire with the black stripe, to ground, right now we should get nothing because the switch is not in the off position and we do not get a connection. So I don't think it's the switch shutting the engine down. As far as this low oil light goes, we have this white wire right here, which should be a ground wire. So I did check it already from here to the ground on this lug, and we got nothing. But instead, if I check the white wire on this connector, which runs up to the module, we get a connection. And that just leaves the middle wire here on the connector, the yellow with the red stripe, and we get a connection there. So just as a double check, I'm going to check it to ground, and we get nothing. So the issue isn't in the control panel. You know, my best guess is that the switch inside the engine might have had some sludge in it. You know, potentially it has freed up now that the engine has warmed up a little bit. So what I'm going to do now is just reconnect, actually this connector right here. Actually, I'll connect both. We'll kind of leave this loose. We'll start it again and see if things are different. All right, let's give this a try. I've got the control panel reconnected as well as the low oil switch to this module. So we are fueled up. The choke is on. So let's see if it'll run without shutting down. I'd like to say I fixed it, but I didn't actually find a problem. I mean, everything is now reconnected the way that it was when we started, only this time we are not getting a low oil alarm. So yeah, most likely we're just dealing with some sludge buildup in the low oil switch. And now that the engine has run a few times, you know, the oil has thinned out. That new oil I added on top of the old has kind of circulated and mixed in and likely just loosened things up. So I'm going to take a second, just get this reinstalled. I'm going to let the engine fully cool down. We'll try it again. And assuming we can keep it running, I'm going to let it run a little bit longer to build up some more heat. And then I want to do a complete oil change. They do not make it easy to get this carb off. There is one bolt right there. I think I can get a wrench on it, so that I'm not so concerned about. But the other one's on the top left, and it's impossible to see because the throttle plate is blocking access from this direction. And even if I try to move that out of the way, there's just no way to get a socket or anything on there. So I think I'm going to have to skip ahead a bit and get the tank off. You know, that had to come off anyway. So once that is free, we should have the access we need to get that carb off. I'm a little surprised, actually, given the age of this machine, to see an AVR down here. It looks fairly typical of what you'd see on a Predator in the 3000 watt range. Also, we have what I assume is a bridge rectifier for the DC output. Anyway, this cover had to come off because there are two nuts right here holding the tank on. So we'll get those out. I think there's a couple more bolts around the corner. And with any luck, the tank will be free. And there's one more bolt behind this heat shield, so I'm hoping removing the shield will give me the access I need. I managed to pull this tube back out, so we will circle back to that later. As far as the carb goes, this one, I was going to say kind of looks like a Mikuni, and it says it right there. You can tell because of the way the jet is on the pilot and the drain. Usually they use a screw like this, which sometimes can get stuck. In this case, it is coming out, but the drain seems to be clogged. So let's just remove it altogether. See if we can get the fuel to come out. And no. So the bowl is still full, but the drain is blocked. Anyway, I think, despite what I said earlier, I think someone has been in here before. The bolts holding it onto the engine were fairly loose, and actually the bowl nut was too. So it's been cleaned at least once. That looks pretty clean. And wow, that's kind of a mess. Looks like water, actually. And this stuff here, I want to say it's rust, but I am not really sure. So, yeah, that's why the drain was clogged. I mean, this bowl is just a disaster. I'm really not sure how this thing was running so well. As far as the rest of the carb goes, it actually is fairly clean. So this bowl is quite surprising. So yeah, I'd say a little bit of water was in there for sure. And I guess we kind of knew that because the tank also has rust in it. And fuel doesn't do that. Water does. Needle looks decent. That is the main jet there. Let's try to get that out. Yep, that was pretty easy. The emulsion tube looks to be removable. Yep, that's coming out. Looks pretty good. And then we have the pilot jet right there. A little bit dirty. And then this right here is an adjustable needle for the pilot circuit. So let's just see where it's set at right now before taking it out. So it's 1 turn, 1.5, about 1 3/4, a touch over. And that's it. I'm going to leave that on. That is just the idle set speed, which isn't really used in this application. And yeah, I mean, the carb itself is in very good shape. The bowl, luckily, it's a very thick gauge metal. You don't see that on newer machines. So even though we have a bunch of corrosion down there, even if I sand and scrape all that off, there's still going to be a lot more material left than a brand new bowl on a machine today. So that shouldn't be an issue. So let me get the Dremel out, clean this up, maybe get a bit of carb spray and just get the heavy dirt off, and then we'll soak this in the ultrasonic. Yeah, I don't think this is actually rust. I'm not sure what it is. Or if it is rust, it's not from the bowl. It may have just come down from the tank. That is dirty. Things cleaned up pretty well. At least the top part did. The bowl, I mean, it's clean, but there is a lot of pitting. So at some point, this is going to be an issue. But for now, there is plenty of material left. So we should be good to go. The one thing I noticed is that the bowl gasket, it's actually broken in several spots. So we do need to get that replaced. That part is not available, at least when you look at the parts diagram. But I do have other Mikuni parts carbs, and this bowl looks to be about the same diameter. So I'm going to get the bowl off, see if that bowl gasket's any good, And if it is, hopefully it fits on that carb. And this one's actually broken. So yeah, let me check my parts bin, see if I have any other options. All right, let's take a look at this one. This is a Mikuni for a Subaru EX27 or EX30. And I know this one does not run well. There's just a lot of corrosion on it. Now, the gasket for the bowl actually looks decent. So yeah, if I can get it out in one piece, this one might work. Not bad. Not perfect, but certainly a lot better. And lastly, we got the Pilot Jet. So that one just gets driven all the way in. And then we have the needle, which is part of this circuit. It's actually feeding fuel right up front to a passage that's actually in front of the throttle plate. So that always supplies fuel. So turn this in until it lightly bottoms out, which is right there. And then back it out 1, 1.5, and just a little bit over 1.25. So at this point, this carb is done, except for this issue right here. So to fix that, I am going to use some JB Weld, which is fuel resistant. It's not going to hold up forever, but I think in an application like this, it should last quite a long time. And it's also going to give it some strength so it won't fall out again. So we'll just start by roughing up the surface. That will help the JB Weld adhere. And we'll do the same on the carb body. And got to be careful cleaning this out. I don't actually want to spray carb cleaner in there, so instead I put some on the Q-tip. Because if you spray carb cleaner in there, it's going to go down and hit the needle with that neoprene tip. And depending upon what carb cleaner you use, it actually will cause that tip to swell. And at that point, it'll be no good. And just a very thin coat. Most of this is going to get pushed off anyway when installing this. It's a very tight tolerance, but there should be just a little bit left to seal things up. Perfect. All right, before we start cleaning the tank, let's just get a good look at the starting point. So right now we are looking down the length of the tank, and honestly, it's not that bad. I think this will clean up pretty well. There is some rust scale, so that stuff can be knocked off pretty easily with some nuts and bolts. So I think I'm going to start there. We'll put some nuts and bolts in there, some hot water, just shake it around, get kind of those chunks broken loose. We'll get those out, and then I'm going to put some EVAPO-RUST in there, and we'll just let it soak for a couple days, and that should take care of the rust. Now, there may only be one flaw to this plan, probably more, but this tank has a lip on it, so I can only get so much out when tipping this tank upside down. So likely I'll have to use the shop vac to just kind of suck it dry to get all the chunks out. The alternative would be trying to drain it from this line down below, which is leaking. These valves always leak, so we'll replace that at some point. Yeah, it's shocking how poorly made these valves are. I mean, that one was not brand new. I actually saved it because it was used. I was kind of hoping it might be a little bit better than the newer ones I buy, which are pretty much just as bad. All right, let's see if this one holds. Yep, that one's good. All right, I think we're pretty much there. So I'm going to try to drain the rest of the water out through here, which, yeah, I can tell already it's not going to work. So, yeah, let's get the nuts and bolts out. We'll have to use the shop vac to get all the water out. I wouldn't say it looks a whole lot better, but we did knock quite a bit of rust out. So that's only going to help the EVAPO-RUST do its thing faster. You know, that said, it's still going to take a couple days. So let's get that EVAPO-RUST in there and hurry up and wait. It's the next day, and I fully planned on leaving this for a few more days before checking back. Anyway, I just happened to be walking by, and I looked down and saw the cardboard that this was sitting on was all wet, as well as the towel underneath. Thankfully, though, the tank is not leaking. That second valve I put on is. So I added another, so now we're doubled up. So hopefully it'll hold. While we wait for that tank to clean up, I'm just going to clean up the side of the block here. We'll get the carb bolted back on, and then I want to turn the machine around. There's a couple issues on the control panel that I want to take care of. Yeah, definitely no torque wrench on this one. And to be honest, these weren't that tight, and it was running quite well, so I'm not too worried about it. That should be good. I'm tempted to fill it with fuel and just test the needle and seat, and of course, the repair. You know, it's actually been 48 hours, so that JB weld should be fully cured. That said, I want to give it as much time as possible, so we'll come back to this. For now, let's turn our attention to the control panel. I just took a second. I got the control panel off again. The thing I really want to fix is this switch. You know, although technically it still works, you know, the face is broken and the light is burned out. Now, this is a discontinued part. Actually, the light they still make, so I could replace the light and just leave the switch as is, but I wanted to check online to see if I could find something compatible with the cutout that we have here. So, you know, I measured this up. It is 12.2 millimeters in each direction. So, you know, I did a search on Amazon, and I did come up with a switch that I thought was going to work. You know, it was advertised as 12 millimeters. But now that it's here, I can see it's not exactly that. In that direction, we're at 10.3. And in the other direction, we are actually closer to 12. It's actually 12.1. So technically, this switch should probably fit. It might be a little bit loose. The other thing, too, which I had meant to get was a momentary switch. And instead, this is more of a toggle, which, again, will work. But it's not quite what I had in mind. So I ordered up another switch that might be a little bit better fit. So I'm going to hold off on that for now. But either way, the switches I found, although some of them had lights like the original, none of them were the right voltage. So we're going to have to eliminate the light. But I do have other lights, pilot lights, for generators. This actually I picked up for the Yamaha EF3000. I think it was a pack of 5. And of course I only needed one. So I do have a few of these. So I'm thinking, we'll put in a standard switch without a light, and we can just add this optional pilot light. Now, this one does run off of 120 volts AC, and if you look at the front of the panel here, we have it kind of divided into a DC section and an AC section. Initially I was thinking it would be nice to put this light, either right here or right there, but the more I think about it, the more I want to keep AC on this side. So, with that in mind, we could probably put it, somewhere right there. Although there are quite a few wires there. So instead of doing that, we could locate it somewhere else, potentially right there, which I think is actually a good spot. So for now, while we wait for the other switch I ordered up, I'm thinking we can just drill the right size hole, get the pilot light installed, wire it into the 120, and then just wait a couple more days for the correct part. Yeah, I will say I kind of hate the idea of modifying this. This part, they don't make it anymore. And right now it's pretty much OEM. That said, I think a pilot light would be nice. I think that'll do it. So polarity doesn't matter on this light. It is meant for AC. So I'm thinking one wire right there, the other one right there. So let's just cut these to length. We'll add some ring terminals and just double up. All right, well, I forgot to hit record. You didn't miss much. I just added these 2 ring terminals. They are soldered on, and although it's very hard to see, there is clear shrink tubing on there. So all we need to do now is just attach them, and that pilot light should be all set. There we go. "24 hours later, and Amazon delivered my new switch. Unfortunately, I thought it was a momentary switch, when in fact it is a toggle switch just like the red one. Also, dimensionally, they are identical, so there's really no difference between the two other than the color of the switch. And that said, I'm glad I got the black one because it's going to go a lot better on this orange and black control panel than the red one would have. So let's cut out the old switch. We'll test fitting the new one, and if everything looks good, we'll solder it up and move on. So the black wire and the white wire we do not need. That is the power for the light bulb, which I believe is 28 volts DC. At least that's what the original light bulb was set at. So we'll just put some shrink tubing on these. We'll cut these down to kind of minimize the chance of this arcing out. The wires we do need, though, are the green and the white with the black stripe. So we'll just cut it right down here at the bottom. Going to try to remove this carefully because there is a chance that the new switch might not work as planned. Seems to be a nice snug fit. And it looks pretty good, actually. I was worried there was going to be a lot of slop in there, but it's not moving at all. So I think this switch is going to work out fine. We just need to connect the green wire and the white one with the black stripe. I'm going to start with these two wires here, the black and the white with the black stripe. These are the ones that would have been sending DC power to the light, but since we don't have a light, I want to make sure that those aren't going to touch anything, especially the white one with the black stripe. That is positive. So I'm thinking just a bit of shrink tubing, maybe a bit of electrical tape should keep that one out of harm's way. I was getting ready to put the control panel back on, and I thought maybe we should take a look at this sediment bowl. I'm sure it's dirty, and the fuel valve, it's kind of weird. It feels loose, but it doesn't actually turn. So that, I would say, is an issue. You know, I don't want to force it, don't want to break anything, but it might already be broken. And I don't like that play in it either. Even if it moved, you know, I kind of wonder if it's going to leak. So, yeah, I'm thinking maybe we get this off, or possibly maybe just some WD-40 right in here might help loosen things up. And it is flowing through, so it's actually in the on position right now. So it's good that it's not clogged. Oh, yeah, it is moving. It is pretty tight. So, yeah, let me get a little penetrating oil right there. I'm just going to work this valve a bit, see if I can free it up any. That did it. Jeez. Seems to work fine. So, let's see if we can get that sediment bowl off. And we'll try to clean that up. Yeah, that is really on there. Don't want to break it. You know, it's not clogged. I'm sure it's dirty. We should probably get it off and clean it. There we go. Yeah, bunch of rust in the bottom of that bowl. So we'll spray that out real quick and put it back. That should do. All right, so what do you think? Is the carb fixed? And is the oil sensor going to work? I guess we'll find out in a minute. So, we'll get the engine started. Hopefully everything goes as planned. We'll also double check that the green pilot light works and that the new switch can shut the engine down. It's taking quite a bit of fuel, so I'm thinking that needle and seat aren't working. Guess we'll find out in a minute when it starts flooding over. And there we go. We're flooding. Yeah, it's holding now. So I'm actually going to drain the bowl out. We'll try this again. All right, let's try it out. I'd say that was kind of a mixed result. I guess first off, the carb isn't running as well as it was. It was struggling a bit. It was harder to start, but I guess on the good news side, we seem to be dry right there. The pilot light is working well, and for a second, I thought we were okay, but the low oil system did kick in and shut things down. So I'm actually not sure if the switch works. I didn't actually try that. So I'm going to get it started again. I'm hoping that it can run a bit longer and avoid that low oil shutdown. We need to build some heat up, and then once we do, we'll test the switch and do an oil change. Yeah, that was a lot better. It was much easier to start. We continued to look nice and dry right there. And the low oil system did not kick in. So those are all very good signs. The switch, though, did nothing. So either I wired it wrong or maybe the switch just doesn't work. So we'll check that out in a minute. But for now, while it's hot, let's get that oil changed. Well, there's a look at the oil that came out, and it's not as bad as I imagined. I'm not sure if that's enough to gum up the oil sensor. I guess only time will tell. I think I see where I went wrong here. Initially, when I cut the wires off the old switch, I said we needed the green wire and the white wire with the black stripe. But when reconnecting it, it kind of threw me because down here in the positive terminal, we also have a white wire with a black stripe, which we definitely don't want on the switch. But now that I'm looking closer at it, I think they used that wire for two different things, because on this connector, we also have a white wire with a black stripe, and that goes up to the ignition coil, and that's what we want to do. We want to send the green ground to the ignition coil. So let's just cut that zip tie. We'll strip a bit of wire, just verify that this wire goes here and not there. And if that's the case, then we'll pull off this one and just swap those two. All right, let's see where this wire goes. Got the meter set in continuity mode, so it just beeps when we have a connection. So we'll hold one probe right there on the white wire with the black stripe. We'll touch it down here on the red terminal for the DC out, which is also a white wire with a black stripe. And we get no connection. So yeah, that is a little bit misleading. And the other wire that's white with the black stripe is right there. And we get a connection. So yeah, this actually is the wire that should be right there. So let's try to free this from the switch. If that doesn't work out, I actually have another one. So yeah, let's try to save this switch. Worst case, we do have a backup. All right, let's try this again. Pretty much the same test, except this time the correct wire is on this switch. So when the switch is out, we should be able to start it. To shut it down, you click the switch so that it's in. So then it's connecting those two wires together, shutting the engine down. Nice. At this point, the fuel tank is more or less ready to be drained of the EVAPO-RUST and reinstalled onto this generator. That said, I don't want to do that yet, because once I do that, I lose access to this carburetor. And there are a couple issues, I think, with this carb. And I guess first off, the needle and seat, they seem to be mostly working. But if I give it some time, I do see the fuel level slowly drop. So potentially that is something we can improve on. I think the bigger issue is just that now that it's been cleaned and reassembled, it's running actually a little bit lean. Without a load, with the choke fully off, the governor rod and the throttle plate, they're constantly moving, trying to find a stable place, which it never finds unless I apply a bit of choke, and then things smooth right out. So what I want to do is just restart this, kind of show you what I'm seeing, and then I want to try a 750 watt load, see if it runs any better or worse under a moderate load. hopefully that came across, but we are definitely lean. Without a load, choke off, the throttle plate was moving all around, and it didn't really stabilize until about half choke was applied. I then turned the choke off, tried to apply a 750 watt load, and the engine went to stall. So I took the load off, put partial choke on again, and then put 750 watts on. And this time it had no issues running. So yeah, 100% we are running lean. Now, as far as the cause, I guess that's what I'm trying to figure out here. The first thing I tried was just spraying a little bit of flammable gas along where the carburetor meets the engine, just to make sure the gaskets were good. If that was the issue, then the surging would have stopped when the gas kind of went in where it was leaking. But I didn't see that. So I would say the gaskets are fine. The other issue is we don't have an air box and an air filter. And by adding those things, it is going to run a bit richer. I don't think it's going to richen it up enough, but I think we should at least try that before digging back into this carburetor. Now, this carb, it does have one adjustable needle right here, and I've actually already fiddled with that a bit, and that really makes almost no noticeable change. So yeah, if I had to guess, I'd say the pilot circuit isn't doing so well. I guess one thing we could try is to start it up again and manually hold it in the idle position. See if it can idle. If it can't idle, then we know the problem is here. So let's try that real quick. Assuming that fails, we'll move on, get the airbox and an air filter installed, and try that out. No issues with that pilot circuit. I could idle it down pretty low, and it ran quite well. So let's add the airbox, the filter, and see if that makes any appreciable difference. As far as the air filter goes, this one's kind of a strange part. I took a look online. Of course, it is discontinued. That said, I did find someone selling it in the Czech Republic who would ship to the US. The only downside is it would take a month to get it. So instead, I'm going to make my own. So the correct part, the filter is cut in the shape of an L, which I assume goes right in this channel right here. The thing that I don't get is that it's tapered here, and the filters that I see online don't seem to be tapered. And even if it was a tapered fit, we still have kind of a channel on each side where the unfiltered air can sneak by. So yeah, I'm not really sure how I want to go about doing this one. If I was going to cut a filter to fit in the channel, I would choose this nice thick one. But yeah, I'm not sure. I just don't think it's going to do a very effective job. So what I'm thinking is that I will cut out an L shape, but I'm going to cut it long enough to go right to the edge of the cover so nothing can sneak by. And then I might have to trim it a bit, to fit in there properly. And that way we have a good seal between the air intake, which comes in right at the bottom, and the carburetor. So yeah, let's at least get the basic shape and go from there. Yeah, I'll take a little bit more off. All right, that length is pretty good. And now we need to make the cut right here. So to do that, I guess we'll just get the approximate size here. So I'm not too concerned about going right to the edge, but I do want to go right to the top to form a good seal. So I'm going to cut something that's going to fit in this channel. So we're looking at about 1.5 inches going down the side. And then for this piece here, about 2 inches should do. All right, let's see if we're close. Yeah, I'd say we're pretty close. We just need to cut it a little bit short right there. And I think this will do a halfway decent job. Yeah, it might be a little too thick. Actually, I think that'll work. Foam filters have to be oiled or they will not catch the fine particles of dust. And for a generator, actually, it's not too important. Usually they're not in dusty conditions, but if you have, something like a lawnmower, a go-kart, dirt bike, even a motorcycle, you gotta oil those filters. Or you definitely risk causing permanent damage to your engine. So don't be afraid to put too much on. You just got to work it in, then use a towel to kind of get out the excess. All right, let's try that out. I'd say there's no appreciable change. It is slightly better. I mean, this time at least with the 750 watt load, the engine wasn't going to stall, but it was surging. And I did have to apply the choke about halfway to get rid of that. So yeah, I think there's no avoiding it. I need to go through that carburetor again. So I'm going to pause it. You've already seen me go through it once. I'm going to do the same thing. I'll just turn you back on when we're ready to test again. Well, I just finished going through this carb again very thoroughly and did not see any obvious problem here. That said, I did still spray through everything with carb spray, ran through everything with a wire just to make sure and did not find anything clogged. That said, I am a little suspicious of the main jet. There seemed to be a bit of buildup on the sidewalls, so I did go through that aggressively. So that is clean at this point. And also discovered the emulsion tube is actually a 2-part tube. The first time I pulled it out, it looked like one piece, so I only cleaned the outer part. This time I was able to separate it and clean the inner part. That said, it wasn't really dirty, so I don't think that was it. I'm just going to get this back together, throw it back on the machine, and we'll try it again. I guess it's the moment of truth. So we're all back together. The carb is bolted on and full of fuel. So I'm going to start it. We'll pay close attention to that throttle plate and the governor rod without a load. Then I'm going to load it like before to 750 watts. We'll see how it does. And assuming it doesn't stall out, we'll take that load off and substitute it for 1300 watts, which is actually 100 over what this is rated for. So let's give it a try. I'd say that was a lot better. This time without a load, the throttle plate and the governor arm were quite a bit more steady. Even under 750 watts, things were a lot better, and it even handled an overload of 1300 watts, and the engine didn't stall out. So at this point, I think I'm going to call the carb good enough. So let's get that airbox back on. We'll drain out the EVAPO-RUST, get the tank back where it belongs, and finish this thing up. It is a week later, and I think we're about as done as we're going to get. I let it sit for about 3 days like this, and then the rest of the time sideways. So at this point, a vast majority of the top should be clean. I think the only exception is right kind of around this fuel fill. And really the only way to clean this would be to get like a bucket, fill it with a couple gallons of EVAPO-RUST, and just dip the tank in there. But I don't want to do that because this generator isn't mine, and there's a chance it could damage the paint or at least lighten it up and make it look kind of different. So I'm going to let the owner kind of decide on that one in the future, if he has problems. So like last time, we'll just pour this out, get the rest out through the fuel line, mop up what's left, rinse it with some gasoline. Then we'll take a quick look inside, see how it turned out. And you may have noticed too, the EVAPO-RUST, it's now pretty dark, and that's an indication that it's absorbed a lot of rust and kind of approaching the end of its useful life. When it's dark like that, it might still work, but it does start to stain the metal more than it would otherwise. All right, let's take a look. Yeah, it's much better. So I'm looking down the length of the tank. That's the bottom right below the fuel fill, the sides, and of course, the top. You can see there's no rust on the far end, but there is rust right by the fill. You can actually see kind of that rectangle shape. So that is the difference between an area that's treated with EVAPO-RUST and one that has not been touched. So you can really see how effective the EVAPO-RUST is. Anyway, let's get this loosely fitted to the generator. I want to get it plumbed in, just flush the lines, test the fuel valve, make sure it doesn't leak. If everything looks good, we'll just tighten it down and finish it up. All right, let me turn the fuel valve on, just flush the system out, and then we'll double check kind of the fuel valve area for leaks. Yeah, it looks like we're good. Nothing's dripping on the ground. The fuel valve seems to work just fine. Now it is a little bit wet right there, but I think that's just the WD-40. So yeah, I think we're good. So let's get the fuel tank secured, get everything back on the machine, and finish this thing up. It is a cold and windy day. It's about 22 degrees. It's about -5 Celsius. So I'm going to go out on a limb here and say that that oil sensor is going to give us a bit of trouble. So we might have to restart it a few times. Once it's going, we'll double check the outputs, and then we'll put a 600-watt load on. Assuming things go well, I'm going to bring the load up to about 1100 watts, which is close to the max of 1200. And once you factor in that light, we are pretty much there. So yeah, let's pull it over, see how it does. Surprisingly, the engine was easy to start, and the oil sensor isn't giving me any trouble. But the engine speed, it's fast at 70 Hertz. I'm going to bring that down to a more acceptable range. Just going to double check the engine speed using the tachometer. It sounds really slow. Just want to make sure the kilowatt isn't misleading me. And no, according to the tachometer, we're at 3,820. So yeah, if anything, it's still a little fast. Without a load, we're at 10.5% THD, and the sine wave looks decent. The THD has come up quite a bit. We're at 26.8%. And the sine wave, yeah, it doesn't look great, but I have seen quite a bit worse. Surprisingly, the THD has not changed a whole lot under this kind of a load. We're at about 27.5%, and the sine wave looks about the same. Yeah, despite the cold, the oil system didn't have a problem this time. The engine kept running, and I double-checked the no-load outputs and was actually kind of surprised to see we were running at 70.5 Hertz. That's about 4,200 RPM. So I brought the speed down to 63 Hertz, at which point it sounded really slow. So I was kind of questioning the accuracy of the kilowatt at that point. You know, if a generator is outputting really dirty power, multimeters can't accurately measure the hertz, but the tachometer can, and that confirmed that the kilowatt was not lying. We were in fact at 63 Hertz. So with that new speed set, the voltage was at about 118 volts, 11% THD. And under 1100 watts, the THD was quite a bit higher, about 27.5%. And the engine was holding just fine at 59.5 Hertz. So yeah, I'd say this machine is done. It's running probably as good as it ever has. So I hope this video helps someone. Thanks for watching. All right, not quite done yet. I wanted to share one final closing thought here. During this video, we had several shutdowns due to low oil, and I kind of blamed it on a gummed up switch inside the engine or potentially a bad module. But now, in retrospect, it kind of makes sense what was happening. The engine was running too fast. It was running at 4,200 RPM, and with cold oil, that oil would be thicker. And the slinger is slinging it at an increased rate, faster than it was designed to do. So likely what was happening is that the oil was being slung faster than it could return to the sump. And that's what was tripping the switch. So now that we're running at the right speed, I'm going to go out on a limb here and say that problem likely will not reoccur. Okay, now I'm done. All right, one last thing. I just want to make a quick announcement. This coming Wednesday, February 21st at 9 p.m. Eastern Time, I'm going to be a guest on Ken's live stream. I will leave a link to that live stream and his channel down below. I will be joined, of course, by Ken and Gary, and between the three of us, we're going to be answering some Q&A. So if you have some questions, that is the perfect venue to ask them. And if you've always wanted to put a face to the voice, well, now's your chance.